Hello, my name is Ian Walker, and today I will be talking to you about how insulation works and why it matters. Some background information. There are estimated that there are 16 million households that are unable to pay for their energy demands. This means that there are a lot of people who have energy insecurity. This means that they are paying more than 10% of their gross income in order to meet their energy demands. This primarily affects poor and minority neighborhoods, and with this quote showing 51% of households earning less than $25,000 report having to cut back on basic energy necessities such as food or medicine in order to pay for energy bills at least once in the past year. This situation can be improved by improving efficiency in windows as well as improving the insulation of their houses. And the reason why we should do this is because it can save money, the environment, as well as save people. So it is reported in 2020 that 1.4 million households had to seek medical attention because of unsafe temperatures within their house. It's also noted that 30% of energy within commercial buildings is wasted. So if we improve window efficiency and insulation, we will save money in the commercial sector, we will save people's lives in the medical sector. It will also help to save the environment because less energy will be used overall. As can be seen here, or in this example, I will show you how a window works with a double pane versus single pane. With a single pane, you only have one conductive layer between the inside and the outside, making energy transfer between it pretty easy. With a double pane, you not only have two conductive layers, which would double the heat, would cut in half your heat transfer rate, but it also has a single conductive layer, which also increases the resistance of heat flow. This is a more advanced example that is essentially a building with a steel plate insulation and a steel plate on the inside. That can be seen with the picture on the left. On the bottom left picture, it shows how this example is modeled as a resistive network. So you have the single steel plate that absorbs the energy, then is dispersed throughout the insulation and the inner steel plates, and then all goes through the ending steel plate. The top graph shows the temperature across the wall. So you have the highest temperature at 0.1, which would be at your interior, and the lowest temperature at 0.4, which is the outside temperature. And as you can see, there's a sudden temperature change after you cross the insulation. The bottom graph also shows the heat transfer rate with the changes that if you were to show with a steel plate and without a steel plate. In this, we want to minimize the heat transfer rate. The standard assumption is with the steel plates included. The no steel assumption is without the steel plates. If the steel plates could be removed, heat transfer would significantly decrease, increasing the resistance, overall making your wall much more insulated. These three graphs shows how different parameters change the heat transfer rate. Graph on the left shows the exterior thickness. Now, in the previous example, that would be the steel plates, the outer steel plates. This shows a linear decrease. As the walls get thicker and thicker, the heat transfer rate goes down linearly. The bottom graph shows the interior thickness. This is the insulation layer. So as you thicken just the insulation layer, your heat transfer rate drops exponentially, which is much better and much more, it makes the walls much more resistive at a quicker rate than what just the exterior plates would. The last graph on the right shows how the area of the wall affects the heat transfer rate. This pretty much shows that the greater the area of the wall, you have a linear trend on how the heat transfer rate increases as the area increases. Lastly, I'm going to be showing you how different insulations affect things. An insulation substitution that I chose was plastic bags, comparing it to the fiberglass insulation of the previous example. There's a 90% difference in between plastic bags and the fiberglass insulation. Although the plastic bags do not provide much of a resistance, it is a decent example because plastic bags are a waste product and can only be used between 2 and 3 times before they're all but useless. This gives a viable alternative to the same material and allows it to be used in multiple situations. As a recap, I have showed you how insulation works with an example of a window and an example of a wall, and I have explained to you how and why this matters, because insulation can easily make the world better with very little cost to it. Thank you for listening.